bonjour à tous. Merci.
Good afternoon, one and all. Thank you all for being here today. Thank you to our panelists for sharing their insights on space weather and solar storms. On the 10th of May, a solar storm happened, and this is something that was not very well covered in the media, but it was quite something still, as we'll see. And we have our 4 speakers with us who will explain why this can have an impact on our lives. Mathieu, BARTHELEMY, you are a lecturer at University Grenoble Alpes, and you are a specialist, an expert on space weather. What is it about? Good afternoon. Space weather is the study of disruptions related to solar activity. So as you might all know, the sun is sending us light, but also particles. Particles that are mainly electrons and protons loaded with electricity that will come closer to the Earth. And when they reach the Earth, they're going to entail a number of disruptions. And one of these disruptions is actually quite beautiful to look at. It's northern lights. So this is quite nice. However, there are other disruptions that can be more troublesome. So space weather is really about studying these solar flares that are going to send us flows of particles that can be extremely varied. And in the event of a solar flare, these disruptions can be more significant. So every 11 years, these solar flares become more common and more intense, and we are reaching this new 11-year cycle in 2025. So if we're talking about this solar storm that happened last May, what was it triggered? What kind of phenomenon triggered it? So these are ejections of major particles coming from the sun, and 7 happened at the same time in May. And when they reached the Earth, they led to disruptions. So if you were outside in the night between the 10th and the 11th of May, you probably saw northern lights, which is quite a rare occurrence in France. And on top of these auroras, there can be other disruptions, including for satellites, communications, and on the slowing down of satellites. And this can also impact maritime transport or aviation because of these solar flares. So what does it mean? SatNav does not work anymore. GPS is disrupted. Yes, the GPS can start giving instructions that do not make sense. So GPS, any other system. So we talk of GNSS or Global Position System. And sometimes you can have a margin of error of up to 1 kilometer. So you can imagine the disruptions that this can cause. So the satellites might lose altitude quite suddenly, and this also can disrupt communications. For instance, the Starlink networks registered some disruptions on their communications. This can also lead to more serious events, and we can even lose satellites. And in 2003, we had a similar occurrence, and 3 major satellites were lost. So you talked about 2003 and 2023. So in the meantime, there were no major events of this extent. Well, 2003 was the last storm of this scale. However, it's quite frequent to witness that kind of events at a smaller scale that can still lead to disruptions. In 2015, there was a disruption on communications for civil aviation in Scandinavia. So we can see events on a smaller scale than what we saw recently that can still entail disruptions. And in 2002, some Starlink satellites were lost. Denis Bousquet from AXA XL, you insure satellites while they are in orbit. So what kind of damage do you provide insurance against? So we insure against any type of damage, including damage related to space weather. So we need to identify the type of events that can damage a satellite and which satellites would be most sensitive to this type of events. So there are three types of damage. First of all, the ground effect. First of all, so it's a particle that can go through the structure of the satellite and can damage the electronic chip. And it can lead to a breakdown of the satellite. The second effect is a load-unload effect. So particulate can build up on the surface of the satellite, reaching a level leading to an electric arc with, similar to a lightning. And usually this leads to the breakdown of the satellite because it's a sensitive piece of equipment. Thirdly, we can have the interaction between the atmosphere and the solar particles. So the lower layers of the atmosphere can be changed because of this. And if satellites face an atmosphere that is denser than expected, then their orbit is going to go down in terms of altitude, and then they will enter the atmosphere and they will burn. So as an insurer, we try to look at the historical events in order to predict the future. And from what we saw, the damages to satellites related to space weather were 3 times lower in 2024 than in 2023 because manufacturers improved the design and protection of satellites to make them more resistant to this type of events. However, and this is why we are discussing it today, there are still some new risks. We see new types of satellites on the market. First of all, the flex-in satellites, telecommunication satellites, and you can readjust their mission remotely from the ground. So, for instance, you can have an internet satellite switched to television broadcasting in Africa, for instance. Another type of satellite is the small satellites, CubeSat, only a few kilograms. They are quite lightweight and quite cheap, and they are used for testing purposes. And so they might break down and because of space weather. So this is a risk that is taken into account by insurers, but it depends on the types of satellites. Okay, and it doesn't mean that satellites are becoming more robust over time. It all depends on the type of satellites. And Marc Legendre, so we're going to discuss the impact of space weather on your satellites because you are a satellite operator. But first of all, can you tell us more about EUMETSAT? EUMETSAT is an intergovernmental organization at European level. We operate the weather meteorological satellites, and we have a fleet of about a dozen satellites. Our mission is to design, to develop and operate a satellite system to observe the Earth and climate. And we do not talk about clients, but more users, because our data is made available to all EU members and scientists. So we have quite an extensive history of data. And we also make this data available to privately owned companies. So this can be useful for maritime routes, for instance, for marine transport. You study the climate of the Earth, but to do so, you need to have satellites that can be impacted by space weather and solar storms. Do you have any example of damage suffered by your satellites, and any changes in your operations or even the design of satellites? Well, we regularly encounter these phenomena that were just described. To take the example of radiation and these electrically loaded particles that can go through the insulation of our chips or components, and that can affect the memory of a calculator, for instance. Because we wanted to reduce the transmission on land. So there's a lot of computation happening in the satellite itself. And so when the computation system is damaged, the satellite will stop. So unfortunately, it means that the satellite will stop operating. And sometimes we can solve this from the ground in a matter of minutes or hours. There's also the impact of the atmosphere, atmospheric trails. And we have some missions to measure the height of waves or water, and to do so we need to know very specifically the position of our satellites. So to do that we use GPS and atmospheric trails. So when there's a solar storm that changes this density, then the satellite will not be in the expected position, and then this measurement will be downgraded. And we can also have the impact of atmospheric trails on space waste. So when there's a solar storm, then the trajectory, the route of this waste will change. And last year, we faced 2 incidents. And we had an alert of a collision only with a 6-hour notice, which is very uncommon. And so it was a reminder of how we need to manage that kind of risk. That's a very short notice. Yes, exactly. When you operate a satellite and you need to find a way to control it from the ground, yes, that's a very short notice. Mathieu, BARTHELEMY, when talking about the impact of solar storms on marine transport, do you have any examples of the impact of solar storms on aircrafts or ships? Absolutely. There can be some significant impact. Taking the example of a marine transport, the 2 main issues will be related to the change in position with GPS, and also communication problems, because the communication between the ships and the shore are very important. So if there are any disruptions related to solar activity, there will be disruptions both on GPS and communications. And these are crossed issues as well. Now, regarding aviation, we face similar issues. First of all, communications, because we know that for planes to land, pilots need to be able to communicate with staff on land. And there's another problem in aviation. It's the dose of radiation received by passengers, and especially by the crew, because they are often at that kind of altitude and therefore more exposed. And we know that there are some annual maximum of radiation received that should not be reached by pilots. And if, because of a solar storm, we reach this limit early, then they run the risk of not being able to fly for maybe 1 year. So sometimes we also need to change a route in order to avoid areas where the radiation risks are higher. So problems of positioning, of location, problems related to communication and radiation, well, these are major disruptions. Right, Denis Bouquet, do you have any figures on these incidents? So first of all, we can have a disruption in these services, and then we cannot send an expert or surveyor to investigate this on the satellite unless there are some volunteers here in the room. So we can only, so when the investigation concluded to a factor of space weather, we're talking about a claims value between 500,000 and 1 million euros. So if we go even deeper, so there was the Starling phenomena in 2002, and they were not insured. So they decided to launch their 40 satellites all the same, despite the solar storm forecast. And out of the 49 satellites, 40 disappeared in the atmosphere because they could not reach their orbit. So we estimated that 18 satellites over the course of 35 years were lost to space weather. And if we look at the cause of breakdown, we realize that about half come from a problem of power generation, so related to the particles we were mentioning earlier, and the other half coming from a breakdown of electronic components. So all of these events lead to some damage, and some of this damage is insured, and the insurers are very cautious about this.
So we could really see what it was all about, how that can be explained, the impact that it has. There's something positive about all that. We can anticipate these phenomena, fortunately, to reduce their impact. But with what tools, Mathieu Barthelemy, how do you go about it? Well, there's a panel of tools that is really large and that depends on risk. There can be material protection making electronics less sensitive to a singular event, or make solar panels less sensitive to charge-discharge. So these are solutions that we'll call technical solutions, and then there are solutions that are about trying to forecast disruptions. That requires an awful lot of data, because we need to be able to forecast a solar storm. Once it leaves the sun, it reaches us, it will take 2 to 3 days to reach the Earth. And we have satellites before the Earth in a point called the Lagrange point that's 1.5 million kilometers from the Earth, still on the Sun to Earth axis. And when the disruption reaches this Lagrange point, we have 30 to 45 minutes left. Then it gets really short. So we've got in situ measures. If you see something leaving the Sun, you may know if it's strong, but you can't really distinguish between strong and exceptional. Once it's at 1.5 million kilometers, you've got your satellites, you can start taking action. However, 30 to 45 minutes is short to take action. So we need a lot of data that are very easily accessible, and then we need to have decision chains. The data issue is essential. We need global access. Most space weather data are public, but in a way they need to be accessible, easily accessible, but also understandable for operators. And all that is very important. They need to be understandable for operators that are not necessarily specialists in the field. What a great segue. Olivier LAMBORELLE, you're a representative of Space Application Services, and you're the head of a network of researchers that ESA, the European Space Agency, is a part of. So what tools are we talking about? What about data collection, Olivier? that Mathieu Barthelemy was talking about? Well, the Space Agency is taking that very seriously because there's a solar weather coordination office based in Darmstadt, Germany. They're working on two aspects. So data collection, as we've said, collecting from data about the phenomena themselves from sensors on satellites, and potentially with partnerships with existing satellites to try and get extra sensors on board on these spacecraft, or also sensors on the Earth, or possibly dedicated missions. We'll have Vigil, a dedicated mission from Europe, to observe the Earth and the Sun from the side to see a full phenomenon throughout its duration. That's the data collection part of what the agency is doing, and then we make data available and use them, and that's through a European network bringing together about 50 research institutes making data available. And here we've got a portal. I can say a few words about that, but anyone can get access to all the data free of charge without needing to visit the website of these 50 research institutes. Everything is centralized and available. ESA Space Weather Portal, that's the name. Yes, ESA Space Weather Portal, Google it. Available to all users, especially maritime shippers and aviation? Yes. What is specific? We said how difficult it is to interpret the data sometimes. Where this portal is successful is that data are organized not based on their scientific category, but because of their user categories. So satellite manufacturers, satellite operations, aviation, Northern Lights tourism, what have you. You get to the portal depending on your sector of business, and you get the selection of data that are the most adequate for you. We don't yet have the maritime sector, but do contact me and maybe we can find a way with ESA to develop an area for you on the website. But you can plan your best trip to Lapland thanks to the portal. But what's the time frame for the forecasts on the portal? Well, it runs the full gamut of forecasts, really. The solar activity. There are solar activity areas that are monitored on the sun, so then you have a major event likelihood, such as solar flares or coronal mass ejections predicted for the next few days. Then if a phenomenon happens, then we start running the models and we'll have forecasts from a few hours to a few days once again. But all these phenomena, even though you can see them appear on the surface of the sun, they will be also modulated by solar wind and the environment between the sun and the Earth, depending on the accumulation of previous events. So these forecasts are not easy to do. So on the portal, you'll have the raw data, but also synthetic indicators that are probably more useful for lay people. You know how high the risk is or not based on thresholds, or even a space weather bulletin prepared by a human expert analyzing the whole situation every day. So they will make forecasts just as any meteorologist will. Mathieu Barthelemy, I think you've been working on that. There are working groups and research groups looking at that. How can you further improve the forecast horizon? You all said that time is of the essence with that, but how can you improve that? There are a lot of factors. Yes, there are a lot of factors, and it's complicated. You can try to better forecast the flares that will come out of the sun by looking at the sun, by looking at the configuration of these active areas and regions of the sun. And you can start forecasting when they will generate flares, but it's still difficult to do. And is that flare going to be intense or not? We have a lot of indicators, statistical indicators, but we're getting physical indicators now. AI is a big help in that to try and improve this time horizon. Then once the event has left the sun, we need to have more precise instruments, and the Vigil mission will be very interesting for that. To distinguish between something that is left but is strong yet traditional, or something that's absolutely exceptional. There it's still difficult for us to distinguish, and we need to be able to describe this journey between the Sun and the Earth. And then the last point is to try and better forecast the impacts based on the parameters that were measured early on, be able to anticipate on the impacts, that there will be impacts on the atmosphere. Are we going to get northern lights in France or not? Or will there be disruptions to civil aviation, the GPS, and so on? Therefore, predicting these impacts is being able to reconstitute a chain between the Sun and what's going on the Earth. For that, there's still a lot of work left. We need more measurements and more models, as very often in science, in fact. This is really important. So we need more satellites. Satellites themselves measure space weather parameters. And so with these satellites, we can better describe the impacts when they reach the atmosphere. There's a very big challenge around that. There's an ESA mission that is going to measure the Earth impact called Aurora. It's a monitoring mission for impacts on the Earth. We already have a lot of tools and data available. Olivier LAMBORELLE, this portal, is it really fully used? Users, we are all potential users. Do they really use it? Well, we have to recognize that it's still growing, because there are 4,500 registered users, 5,000 at the most, 2 million visitors a month, but there's still a gap between the volume of scientific data and the use that's made of them in the various sectors. So the way the portal is structured helps make the data usable, but we still need to do more. That's why the Space Agency organizes targeted communications campaigns, sector by sector, whereby scientists and more operational people can meet to discuss their respective needs. We can also influence data production. The Space Agency can guide some scientists, telling them, if you develop a product in this area, there will be more users. And then at the same time, we need to understand whether a product is really useful and will be used by the community. There are opportunities for dialogue. Well, in the marine sector, for instance, Denis BOUSQUET, are you using all these tools? Well, yes, for an insurer, it's very interesting. As Mathieu said, there's already raw data, historical raw data over several years. We can see a lot of major anomalies for satellites, and we'll try to correlate these weather events, these particle flows, or these weather clues, and the damage that we can see, the anomalies that we can see on satellites. Then once we've seen a correlation for a type of failure, we can improve our likelihood model for first occurrence or reoccurrence, depending on whether it's a new or existing satellite. That's for data. Regarding forecasts, whenever you subscribe an insurance policy for space, we will look at the data for a year, so we need a forecast over 1 year. Mathieu talked about a few hours or even days. It's not yet enough for insurers, but we don't need such precision for operators. We only want trends. And you get those trends for some information, such as sunspots that can be correlated to some anomalies. We've got a long-term trend over a year. For other phenomena like electron or proton flows, then we need more improvements. Are you inviting your clients to use these tools like the portal or others? Are there premiums? If you're a policyholder, if you're a very good student and you are informed, is there an impact on the premium? The premium always depends on the risk, and the fact that the manufacturer and operator will take the space risk into account, that will be part and parcel of the risk analysis. If the operator runs enough tests on components to prove that the satellite will be hardened, they will have a better premium than the others. It's part of overall risk. Now we're raising awareness amongst our new space clients. those launching spacecraft that weigh a few kilos, very often they offer low-cost components that will be less well tested against radiation. So in our technical discussions, we're asking them how they tested some components, and based on the answer, the price of insurance may vary. Then the invitation that we give them in using these tools that will become more natural once correlations have been established officially, and we can prove correlation between weather events and breakdowns on satellites. Then I think everybody will log on to the portal. That's very clear. That's the next step. Now a final word for each of you. What are your respective goals? Mathieu, you've been talking about research groups to further improve forecasts. What's in your crosshairs for the next year? Well, we have many goals. We need to improve models. We have difficulties. These are very complex phenomena. And there are difficulties in improving models. But as in traditional meteorology, we need to have more measurement tools. Having a thermometer is not so difficult, but sending a particle detector on a spacecraft takes more work. It's more complex. So there's a challenge around measurement, the measurement of parameters for space weather. I think someone talked about it already, I think. We need to have more engagement between end users, those who could be impacted by space weather, and scientists, to see, in a way, whether there are unexplained events, and also to guide our research towards some aspects, X or Y, of these impacts. So driving engagement with end users is one of our goals as academics. I think that the other three speakers share that viewpoint. Denis was nodding. That's awareness raising is something that you care about. Yes, more monitoring and forecasting. Our forecasts are much better now for space weather than 4 or 5 years ago. So I'm glad that we're having that type of discussion, merging scientists, users, operators, and people who can provide services. We need to improve one-year trends. That's really specific for insurers. And we need to improve testing, especially on some components and some spacecraft, to improve the reliability of spacecraft. Olivier, more data, more sectors, even finer analysis? Yes, so more instruments, more data collected in space or on the ground. Maybe we want to look at what's going on not just between the Earth and the Sun, but in the whole solar system. There are other missions and challenges beyond the Earth's orbit, and we want to engage the user community to fine-tune requirements and guide resources to the right directions to make infrastructure and human activities more resilient to these phenomena. And you, Marc, at EUMETSAT, even more satellites or even more robust satellites? Well, I'll agree with the other speakers. We need to share more so that we have better grasp of our mission's challenges. Now we'll need another milestone to get more information that we can rely on to decide whether to reroute a mission or protect it. We need to face the fact that solar storms will cause interruptions, but then we are wrapping up the fine-tuning of our latest geostationary satellite that contributes to all the weather pictures that you can see on TV and other measurements. And now we will double the frequency of pictures made available to meteorologists. So that's a big progress for short-term forecasting. Yes, for measurements and new types of measurements, we'll have new equipment, such as an instrument that can measure the position and frequency of lightning continuously on the geostationary spacecraft. That's a first in Europe. So climate studies will be greatly improved. And we're saying that it's easy, we need to make them more this or that. So you're saying we're finalizing the latest satellite. How long does it take? a new generation of spacecraft. There will be 4 in this generation in succession. That's 1 year of work between the satellite and ground processing. It takes a year before we can declare that a product is qualified at the quality that we're expecting. That takes a bit of work, yes. Thank you to the 4 of you for shedding more light on space weather. That was really, really enlightening.